Okay, rational exponents. This is not horrible, but there's so many different types. We can do numbers and letters and negatives, so there's a lot of examples. So just stick with me. It's not bad though, I promise. Okay, so when I say the word rational, this kind of means a fraction. So our exponents are not just like a 2 or a 3 or a 4, they're in fraction form. Okay, and we're going to be rewriting this. This is exponential form. We're going to rewrite this in radical form. So where I have this 4 to the 2/3 power, this is our fraction up here, is power over root. And I'll show you what that means on this side. So my fraction, the top part is the power, the bottom is the root. So how we write that is we write our root. So the root, when I say root, I mean this number right here. So this is going to be a cube root. So the denominator of this exponent represents the root, and the power, the 2, is the power on the inside, or square. So we can go back and forth. Everything today we're going to leave in radical form, but they're going to give you a lot in exponential form, and then you're going to simplify. Is everyone done writing that? Okay. Okay, so number 1, 36 to the 1/2 power. So when you look at your exponent up here, remember it's power over root. Power over root. So when you rewrite this, you write your root, and the 36 goes underneath. I have a 2 out here, and my power is 1. And if it's a 1, you don't have to write the 1, but if it helps you, that's fine. What is the square root of 36? 6. Just 6. So you'll get used to seeing a 1/2 power is the same as a square root. Number 2, 64 to the 1/3. So remember, power over root. I promise I won't mark this every time. Power over root. So here's my root with 64. What goes here on the outside? 3, and then a 1 on the inside. What's the cube root of 64? 4. So those two you'll get pretty familiar with. 1/2, 1/3, 1/4 become 4th root, cube root, and square root. You mean like here, or the, no. The very, like, the last 2 examples I think we do today, they have that, but it's just for simplifying it. You don't have to actually find it. Okay, number 3, 49 to the -1/2. So think back to your negative exponents. When we did something like this, how do I make this positive? Under, right, it moves to the denominator, becomes 1 over x to the 3rd. Okay, same thing here. So to make that positive, it's going to become 1 over 49 to the 1/2. How can I rewrite 49 to the 1/2? Power over root. Yeah, square root of 49. And if you already know 49 to the 1/2, if you know what that is, then just write it here. So if you want to change it to square root, then do that. What's the square root of 49? 7. So 1 over 7. Okay, number 4. Negative 1/8 to the negative 1/3 power. Okay, if you have a fraction, because in here we had a whole number, 49, or like this exit moves to the bottom. If I have a fraction, this negative is going to let me flip the 1/8. And then it's going to become positive. So inside the parentheses now, this is going to become 8 to the positive 1/3. So if you have a fraction, you can flip it and it changes your exponent to positive. So x to the 1/3 becomes cube root of 8. And what's the cube root of 8? 2. So again, if you know that 8 to the 1/3 is cube root of 8 and you're writing just 2, that's fine. Just depends on the person. Okay, number 5. So now instead of just a 1 in our numerator, we're going to add in some other numbers. 36 to the 3/2 power. Okay, same thing, nothing changes here. This is still power over root. Okay, so rewrite it. 36, my root is 2, and my power is 3. When you do this, you could do either order first. You could take the square root of 36 and then cube it, or you can do the other way around. You can cube 36 and then take the square root. Because you don't have a calculator, always do the root first. Always do root first. Because if you try to cube 36, that's going to be a huge number. Then you have to figure out what the square root of that is. But if you do the square root first, what's the square root of 36? 6. So now I have 6 to the 3rd, which is 216. Okay, so make sure you see what I did. I took the square root first. I got 6. And then I did 6 to the 3rd is 216. Number 6. 27 to the negative 4/3. What would you do first on this one? Yeah, make it positive, so put it in a fraction form. So 1/27 to the 4/3. So now my exponent is positive. I'm going to rewrite this. So inside the root I have 27. What's my number right here? 3 or 4? 3, right at the bottom, and then I put 4 on the inside. So do the root first. What's the cube root of 27? 3, and then I raise it to the 4th power, which is 81. So really, at this point right here, if you remember to do this first and just think in your mind, oh, cube root of 27 is 3, then you can skip this step if you want to. Just depends on how you see it. Okay, number 7. Negative 27 to the negative 2/3. Okay, what are you going to do first? Yeah, flip it. Does this negative get affected at all? No, it's just making it a negative 27. So it becomes 1/negative 27 to the positive 2/3. So I do this first. I do the root first. What's the cube root of negative 27? Positive or negative 3? Negative 3, right. So this becomes negative 3 squared. Okay, so I didn't write the root. I did this root first, cube root of negative 27, and then what's negative 3 squared? Positive 9. Be careful when they give you those negatives. Okay, number 8. 16 over 81, and then that's all raised to the 1/4. If you do 1/4, if you change it to a root, what goes on the outside? The 4. So really I'm going to do the 4th root of 16 and the 4th root of 81. So you're just finding the 4th root of both. What's the 4th root of 16? 2. And of 81? So again, you could just look at this and say, oh, I'm just finding the 4th root. They're both raised to the 1st power, so you don't have to do any work after that. And let's do one more like that. Number 9. So try number 9, see what you get. Be careful because there's a negative exponent. Okay, if you flip the fraction because it's negative, hopefully, then this stays positive 3/4. I did the 4 first. I did the 4th root of 81 over 16, which is 3 over 2. And then I cube both of them. So 27 over 8. Did I lose anyone on that one? Okay. So on the next part, we're going to add in variables. So we're going to be combining things with our exponents. And since there's fractions, of course, you'll have to do like common denominators and all that fun stuff. Okay, make sure that all of your answers are in radical form. Okay, go back to your exponent properties for a second. If I was multiplying these, what do I do with the exponents? You add them. Okay, so nothing changes here except that we're going to have fractions. That's all. Nothing crazy though. So this first one, this one. X to the 2/3 times x to the 5/3. When you add fractions, what do you have to do? Make sure they have a common denominator. So do they? Yeah, so just add them. So x to the what? 7/3. Is this radical form? No, it's not. Okay, same thing as we just did, it's just there's no numbers. Power over root. So I'm going to rewrite it. Cube root of x to the 7. Can I simplify that?
Yes.
Yes. So if you want to split it up like we did the other day. So I have a, let's see, x to the 6th and an x to the 1st. And then divide. 6 divided by 3. So x squared on the outside and cube root of x on the inside. So really, once you simplify and you get to something like this, and you rewrite it, then you've already done this part. negative 2/3 power. All right, what would you do first? Yes, make that a positive. So 1 over a to the 2/3. Okay, let's change this to radical form. So 1 over, what goes on the outside? 3, and then on the inside, squared. Can I leave my answer like this? No, why not? What we talked about yesterday.
No radicals in the denominator.
Right, no radicals in the denominator. Okay, so yesterday we looked at things like if we had, say, a square root of 3 in the denominator, what did we multiply by? A square root of 3. Why? What am I looking to get over here? A perfect square. So think about your variables. If I have 2 a's, how many do I need for it to be cubes? I have 2 a's. How many do I need to make this even with the 3? Just 1. I should have said even. That's it. Let me say it again because I feel like that was confusing. Okay, if I want it to be a perfect cube, I would want either a to the 3rd or a to the 6th or a to the 9th. If I have 2, I just need 1 more to make that 2 plus 1. Okay, so I'm just multiplying by 1 cube root of a on top and 1 on bottom. So multiply across the top, what do we get? Cube root of a. And across the bottom, what do we get? Cube root of a to the 3rd, which that denominator just gives us what? Just a. Did I lose you? No, yes, maybe. This is how most of them will be now. Is here you'll get like a squared, you need 1 more a to get rid of it. Or we'll do like x to the 1st, you need 2 more if you're doing cube roots. Let's try another one. A over b to the 3/4. So first thing, change this to radical form. So that becomes a over, what goes on the outside? 4, and then b 3. So what we did yesterday, what do I need to multiply by to make this have 4? 4th root of b. So multiply across the top. Just a 4th root of b. And what would I get on the bottom? Just b. Because this becomes 4th root of b to the 4th, and the 4's cancel. Can I simplify this? No, yes, no. All right, let's try with some numbers. Number 4, 4 over 3 to the 2/3. So same thing with your letters, change it to radical form first. So 4 on top. This becomes cube root of a 3 squared. 3 squared. What is 3 squared? 9. So I really have 9 underneath here. So what do I need to multiply by to get a perfect cube? Another 3, right? I have 9. I would need to multiply by a 3 to give me what perfect square? Or sorry, square, cube. 27. Okay, also look at it like this. Come back up to this A when we did. I had 2 A's. How many did I need to multiply by? 1. Same thing here. I have 2 3's. I need 1 more 3 to get my perfect cube. Okay, so you can look at it like that, so you don't have to always say, okay, this is 9, what do I need to multiply by to get a perfect cube? So on the top, 4 cube root of 3. So our answer here would just be 4 cube root of 3 over 3. And I can't simplify that at all. So try number 5, same type of problem, just instead of 3s, there's 7s. So try this one. Number 5. So again, if you want to change that to 49, you can, but if I'm taking the cube root, how many more 7s do I need to get rid of that? Just 1. Okay, you could change this to 49, but then you have to say, well, what do I multiply 49 by to get a perfect cube? We don't even have 7s on our cube list. So look at it like that. If I have 2 7s, I just need 1 more 7. So I get 14 cube root of 7 over 7. Then this reduces to 2. So we get 2 cube root of 7 as your answer. How are we doing so far? I have 3 more for you that aren't horrible. They're kind of different than this. So number 6. Want me to go back to it? Please?
Yeah.
That's fine. Which part? The very end?
Yeah.
Okay, so this 7?
Yeah.
Okay. Or this 7?
Oh, no. Yeah, that one.
Okay. When I multiply this, I get cube root of either 7 to the 3rd or cube root of, what is that, 243, I think? Both of those, either this one, the 3's cancel and I get 7, or this one I get 7.
Okay.
So what I'm doing, like, come back up here to the A's. This is probably the best one to look at. I've got 2 A's and 1 A. That gives me 3 A's. And the reason I do that is because I know those are going to cancel and give me a single A.
Mm-hmm.
So you can do that with any of your numbers, too.
Okay.
Any other questions on 5? I just kind of went right along. Sorry. Okay. Okay, so number 6. Let me write that down. So when we look at our powers, we have power over root, right? I mean our exponents, power over root. What would the root be for all of these? 4. Okay, they all are 4th root, which means they can all fit under the same radical. So I can make one big 4th root and put all 3 of them under there. I would have 10 to the 1st, A to the 9th, and B to the 3rd. Can I simplify any of those? Which one? Yeah, just the A. So if I break that down, it'll be A8 and A1. So really that's the only thing that can come out. So that'll be A2 on the outside, and then everything else stays on the inside. The 10, 1A, and 3 B's. That's it. Okay, our other exponent property I erased earlier. When we divide, what do I do with the exponents? Subtract. Okay, so same thing here, but we're going to have some fractions. Although generally they'll give you common denominators, because then you have to do stuff later. So x to the 2/3, y to the 3/4 over x to the 1/3, y to the 1/4. So you have to have the same bases in order to do the exponents. So just look at your, I can do the x's together. So I'm just going to subtract 2/3 minus 1/3 is what? 1/3. And then do the y's. 3/4 minus 1/4, thank you. Yeah, is 1/2 if you reduce it. Can these two things go under the same root? No. Oops, undergo. Cannot go under same root. How could I make them the same? Common denominator. If we do a common denominator, then I can put them under the same root. So what is the common denominator between 3 and 2? 6. So this becomes 2/6, and this becomes 3/6. And now they can go under the same root. 6th root of x squared, y to the 3rd. One more. That's a 1/5, and that's a 3/7. I know it looks ugly. It's not bad, I promise. Okay, so we can do our x's, subtract our x's. So x 4/7 minus 3/7 is 1/7. Let's change this 5th root of y cubed. Can I change that to be an exponent? What will my fractional exponent be? 3/5 or 5/3? 3/5. Power over root. And now I can do my y's. This one minus this one. What would that give me? 2/5. Make sure you get a common denominator here. What's common between 7 and 5? 35. So this becomes what? 5/35? 14/35? So this is what I mean, where this is really the only thing you'll see with the weird roots. The 35th root, x to the 5th, y to the 14th. And double check you can't simplify those, but generally these will be smaller, generally, so you can't simplify that part. Okay, so tomorrow is a practice day over all 4 things we've done this week. If you have missed a day, or you haven't watched a lesson, or you haven't done a worksheet,